In the heart of Dubai, a horizontal city is suspended above one of the busiest highways in the Middle East. Its name is the Link, the heart of the Za'abeel megastructure and also the longest cantilever structure in the world. The project consists of two gigantic towers separated by a 6-lane highway and connected by a massive steel superstructure more than 230 meters long. So how were engineers able to lift a structure heavier than the Eiffel Tower to a height of nearly 100 meters? How can a suspended sky oasis, weighing almost 10,000 tons, remain stable in midair using only the connecting forces from the two towers? And how did Dubai turn one of the boldest ideas in the history of modern construction into reality? Today, join Mandarin Tech as we uncover the secrets behind one of the most historic lifts in the history of global construction. Za'abeel. Located in one of Dubai's busiest financial districts, Za'abeel was developed as a new symbol of the city's architectural ambition. Designed by the Japanese architecture firm Nikkei and developed by Ithra Dubai, this multi-billion-dollar complex consists of Tower A and Tower B, with heights of approximately 330 meters and 235 meters respectively. The entire project was conceived as a vertical megacity, integrating an ultra-luxury hotel, high-end residences, Grade A office spaces, along with a vast collection of commercial and entertainment areas spread across hundreds of thousands of square meters of floor space. However, what makes Za'abeel truly different is not the height of its two towers, but the massive structure stretching through the sky above the busy Al Mustaqbal highway. That structure is the Link, the world's longest cantilever structure, weighing approximately 9,500 tons and containing an entire suspended oasis with restaurants, sky bars, and the longest infinity pool in the UAE at a height of nearly 100 meters. The existence of the Link has transformed Za'abeel into one of the boldest projects in modern construction history, a place where engineers did not simply build skyscrapers, but also found a way to suspend an entire horizontal city in midair. For Za'abeel to rise into the sky, the first challenge was hidden deep underground. The construction team had to excavate approximately 42 meters below ground level to create space for the basement and parking areas, while also building 2 underground tunnels to directly connect the 2 towers beneath Al Mustaqbal Highway. After the excavation phase, the project entered one of the largest concrete pours of the entire development. Engineers designed a massive raft foundation system capable of supporting the enormous weight of the 2 skyscrapers, along with the gigantic Link structure above. A record-breaking concrete pour was carried out, with 26,000 cubic meters of concrete continuously poured across an area of 7,600 square meters. However, the greatest challenge came from the fact that the construction site was located only approximately 5 meters away from an existing highway overpass. Throughout the excavation and foundation works, even the smallest vibration or ground settlement could directly affect one of Dubai's most critical transportation routes. To control these risks, a network of sensors was installed on the bridge structure and retaining walls to transmit real-time data back to the control center. This allowed engineers to continuously monitor even the slightest structural movement while traffic above continued operating normally. Once the foundation was secured, towers A and B began to rise. However, instead of being built perfectly vertical, engineers from Nikkei and ALEC intentionally constructed the towers with a carefully calculated outward inclination, using a technique known as pre-cambering. The reason was the Link, a massive superstructure weighing approximately 8,500 tons, which would later be lifted and connected between the 2 towers at a height of nearly 100 meters. Engineers predicted that this enormous load would pull the tops of the towers slightly inward. As a result, Tower A and Tower B were intentionally constructed with an offset of approximately 1.5 to 2 millimeters per floor. Once the Link was fully lifted and installed, its massive weight would pull the towers slightly back into their intended vertical position. Throughout the construction process, numerous digital simulations and structural analysis models were continuously carried out to monitor how the building responded at every stage of construction. Engineers had to predict every displacement, deflection, and rotational movement within the structure to ensure that the entire tower system could ultimately function as a single unified structure once the link was suspended above. While the two Za'abeel towers gradually rose into the sky, the most complex phase of the project was taking place below, assembling and positioning the link structure. To carry out the construction, engineers divided the link into 7 massive steel modules, each measuring up to 51 meters in length and weighing more than 1,700 tons. The modules were prefabricated in factories before being transported to the site for welding, allowing construction tolerances to be controlled at an extremely precise level. Once completed, the link would become a gigantic steel superstructure with a total weight of approximately 8,500 tons. Next, the construction team built a temporary steel rail and sliding platform system, so the entire structure could slowly slide outward into the open space between the two towers. After each new module was welded into place, the hydraulic system pushed the link structure farther across the highway. This process was repeated a total of 6 times. Throughout the sliding operation, engineers continuously monitored friction, displacement, and structural alignment to ensure all parameters remained within calculated limits. The largest sliding operations were mainly carried out at night when the highway was temporarily closed to reduce vibration and ensure safety. After the final slide, the link completely extended beyond the podium structure and was suspended between the two towers. This also marked the beginning of what became the heaviest commercial steel lifting operation ever carried out in modern construction history. To lift this gigantic steel structure, engineers used a strand jack system attached directly to both towers. Multiple bundles of high-strength steel cables were connected to the link, after which the hydraulic system began pulling the entire structure upward in extremely small increments. Instead of lifting the structure in a single rapid operation, the entire process was divided into multiple continuous lifting stages to allow more precise control over loads and structural displacement. As the link gradually separated from its temporary supports, both towers also began experiencing slight deformation due to the changing load conditions. After 3 continuous days of lifting operations, the link finally reached its completed position at a height of nearly 100 meters, connecting Tower A and Tower B with a gigantic steel structure suspended above a major Dubai highway. Immediately after the link structure was successfully lifted into place, engineers moved into the next phase, completing the final cantilever section extending outward from Tower A. This became the second major lifting operation of the project, used to position a steel segment weighing nearly 950 tons. Engineers applied a pre-cambering technique with an upward curvature of approximately 300 millimeters to compensate for the structural deflection that would occur after all permanent loads were installed. The lifting process for the cantilever segment proceeded extremely slowly at a speed of approximately 5 meters per hour and continued uninterrupted for 3 days and nights. After the final section was permanently welded into place, the link officially reached a total length of approximately 230 meters, becoming the longest cantilever structure ever integrated into a high-rise building. To ensure the long-term stability of the entire system, the construction team spent an additional approximately 6 weeks completing the critical weld connections between the link and the tower structure. A total of 142 connection points were inspected using ultrasonic testing and other non-destructive testing methods before the structure was officially placed into operation. Once the main structure of Za'abeel was completed, the construction site moved into the next phase, installing the MEP systems and technical infrastructure inside the link. Because the interior space of the link was extremely limited and located at a height of nearly 100 meters, engineers used numerous prefabricated MEP modules manufactured off-site before transporting them into position for installation. This approach helped reduce construction time at height and minimize installation errors. At the same time, the entire technical system was coordinated using BIM three-dimensional modeling to control installation accuracy and structural integration. During this phase, the building's glass facade was also gradually completed using white ceramic frit patterns designed to reduce solar heat absorption and lower the cooling load under Dubai's extreme climate conditions. Meanwhile, the podium roof below was shaped to resemble desert dunes in order to visually connect with the overall architectural language of the project. However, the most complex element remained the suspended infinity pool above the link. The pool measures approximately 125 meters in length and uses a specialized waterproofing and load distribution system capable of supporting hundreds of tons of water suspended in midair. When approximately 640 cubic meters of water were pumped into the pool, this new load created additional minor structural displacement throughout the link. But just like every previous stage, all of these movements had already been predicted in the structural engineering models. Alongside the installation of the technical systems, numerous hotel spaces, residences, restaurants, and luxury entertainment areas inside the two towers, and the link also began to be completed simultaneously. Tower A was developed as a mixed-use complex containing an ultra-luxury hotel, office spaces, and serviced apartments, while Tower B was primarily dedicated to high-end residential units. The two towers were fully connected through the gallery, a three-level podium containing approximately 12,000 square meters of retail and restaurant space. Inside the link, Michelin star restaurants, sky lounges, boutiques, and wellness spaces gradually moved into the interior finishing stage under extremely strict construction standards. This also became the phase where construction teams had to coordinate electrical systems, ELV systems, air conditioning, lighting, and numerous premium finishing details within the highly complex cantilever structure. To increase precision and accelerate construction progress, ALEC began introducing new construction technologies, such as the MyRow automated painting robot, capable of operating continuously with higher precision than traditional manual methods. At the same time, virtual reality technology and digital engineering models were also used to simulate interior finishing works and detect technical clashes before actual construction began. After many years of non-stop construction, One Za'abeel officially opened in February 2024, marking the completion of one of the most ambitious projects in the history of the Emirate. However, the project's greatest value lies not only in its height or luxury, but in the way it has reshaped the design philosophy behind modern megastructures. Achieving LEED Gold certification demonstrates that Dubai is not only pursuing records in architectural scale, but also prioritizing sustainability. From energy-efficient water-to-water heat pump systems to intelligent glass facades designed to reduce desert heat radiation, One Za'abeel stands as proof that modern engineering can coexist in harmony with the environment. And just as Burj Khalifa redefined the Dubai skyline more than a decade ago, One Za'abeel is now becoming a symbol of the next phase of global construction, where mega projects compete not only in height, but also in the boldness of the architectural ideas behind them. One Za'abeel is not simply the story of two skyscrapers rising in the center of Dubai, but a demonstration of how modern construction is gradually overcoming limits once considered impossible. From excavating dozens of meters deep beside an active highway, precisely controlling every millimeter of structural deformation in the two towers, to lifting a gigantic steel superstructure weighing nearly 10,000 tons to a height of almost 100 meters, the entire project represents a combination of structural engineering, digital technology, and an almost absolute level of construction control. And perhaps the greatest value of One Za'abeel does not lie in its record-breaking numbers, but in the mindset behind it, a future where engineers are no longer simply building taller towers, but turning ideas that once existed only on paper into reality. Thank you for joining Mandarin Tech on this journey, exploring one of the boldest megastructures in Dubai today. If you enjoy stories about mega projects and architectural wonders, don't forget to like, subscribe, and leave your thoughts in the comments below.